Graphing an ellipse in standard form. All right. So we went over in this previous video all of the points, all of the things you could possibly want to know about an ellipse was in that previous video. Now let's use all that information and do something with it. The first thing you're going to do when you want to plot an ellipse is the same thing you would want to do if you were plotting a circle, and it's to plot the center. I want to make mention here that if you look at both of these formulas, you'll notice that it's a minus sign in between the x and the h and the y and the k. It's the same on both of these. What that means, because the center itself, the center is at h comma k. So if there's a minus sign here, it means that whatever you see here, the opposite of it is what is in the center. So if it's a minus sign here, it's a positive number. If it's a plus sign, it'll be the negative version of that number. So for this guy here, that's funny that like those are turning out gray. I don't know if you can see that, but they look gray on here. Who knows what happened there? H is with X, so H is -3 because it's a plus sign, the opposite. The Y value, the K value, the Y value of the center, K, is +2. So we could say the center is at -3, 2. Center is at -3, 2. I'm gonna go ahead and plot it, -3 up 2, and I'm gonna go ahead and put it down here, -3, 2. All right. The next thing we're going to do is determine which of these is a squared and which of them is b squared for these guys here. One of these is a squared and one of them is b squared. And the answer is a squared is always the bigger number. A is always the bigger number. A. Oop. Write it down in your own handwriting. It'll make you feel better and you'll remember it better if you write it down. A is always the bigger number. So I see this 25. I know 25 is bigger than 9. So a squared will be 25. Taking the square root on both sides, it'll be 5. A will be 5. Now, if you are a diligent math student, you may say to me, Professor Cook, if you are going to take the square root on both sides, you simply must do the plus or minus, and therefore A is not 5, A is plus or minus 5. And if that was your intuition, please become a math major because you have that right math major mentality, and there's a lot you can do with math. That being said, A is a distance for us, and we're not going to deal with negative distances. So A for us is going to be +5, and we don't even have to worry about that whole plus or minus business. The other number, 9, is going to be b squared. So b squared is 9, taking the square root on both sides. B is 3. Now, something important has happened because I determined that a came from the term underneath the y term. So a squared was under the y term, which means that the y-axis is the major axis. So the y-axis is the major axis. And I guess I have I have it written down here, huh? The bigger number is under the y term. So the y-axis is the major axis, and that means that the ellipse will be tall, not wide. Taller than it is wide. Oh, and I can fill this in here. 5, 3. We have everything we need to actually graph the ellipse at this time, but I am going to also get C here because we're going to plot the foci this time. So for the foci, C is equal to the square root of a squared minus b squared. And you could plug a in and then square it, but we also have the values of the squares right there. So that's what I'm going to go with. This is the square root of a squared is 25 minus b squared is 9. Square root of 16 is 4. So c is equal to 4. Okay. We have everything we need to plot literally everything in this ellipse at this point, including the foci. So the first thing is either vertices or co-vertices, doesn't matter which. I'm going to do vertices first. Since y is the major axis, the vertices are going to be a equals 5 units. If it's y, that's going to be up or down. So I'm going to make a note here, up slash down, because y is the major axis. Up slash down from the center. So I'm going to come here and I'm going to go down 1, 2, 3, 4, 5 units and plot my first vertex. And so this was 5 units. 5 units, we went that way. Then from the center, I'm going to go up 1, 2, 3, 4, 5 units and plot another vertex. So this was 5 units up. To plot the co-vertices, I'm going to use my b value, which is 3, and I'm going to go 3 units, maybe mark this on here, left slash right of the center. So 3 units to the right. This is going to be a co-vertex. 3 units to the left. Another co-vertex. This is 3, this is 3. And because we're going to do the foci too. The foci are going to be c equals 4 units from the center. So and they're always on the same axis as the vertices. So 1, 2, 3, 4. This right here is one of the foci, 4 units down, right here. This is the other foci. So we'll just color it a little bit so you can see that see where that pink is. There we go. So then all that's left is drawing the ellipse itself. If you're doing this in Notability, if you've seen me using Notability and you've decided to buy it yourself, you can try to make it auto make an ellipse. Every time I do it, do you see how that's crooked? Every time I do it, it becomes crooked. And you can use the selection tool and then it gives you a little handle, but then it like tries to snap itself funny. And oftentimes when it snaps itself too far, although it did a good job that time. Oftentimes with this, I will draw my ellipse like this, and then I will flip it from there so it doesn't try to snap into place funny. Just a tip. All right, and that's it. There you go. It's strong. So let's, and forgot to fill this out, of course. The co-vertices are b equals 3 units left slash right from the center on the minor axis. The foci are c equals 4 units, and they're on the major axis, which is going to be the y-axis, so they are up slash down. All right, the co-vertices themselves, this is going to be the point, let's see, we have the point 0, 2, and over here, this is the point -6, 2. 0, 2, and -6, 2 for the co-vertices. For the vertices, this point up here is the point, where are we? -3, comma 7. -3, 7. -3, -3. -3, -7. -3, -3. The foci, this guy right here, is at -3, 6. This one here is at -3, -2. -3, -2. -3, -2, -3, 6. Whoop. The length of the major axis is 2 times A. A here was 5. 2 times 5 is 10. The length of the minor axis is 2B. B was 3. And that gives us 6. The major axis is length 10. The minor axis is length 6. Let's compare that real quick. Let's just take a look. Is that true? So let's start counting up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 for that length. 1, 2, 3, 4, 5, 6 here. So that is the length of the minor axis, 6. I'd also like to point out these formulas, the formulas to get these points here. So the formula for the tall ellipse for the vertices is h comma k plus or minus a. So for us, the h value was -3. So -3, the k value is 2. 2 plus or minus the a value is 5. So that splits up into -3, and then 2 plus 5 is 7. And then -3, 2 minus 5 is -3. So notice that formula, when you plug those values in, you do get these same points. And I'm not going to prove it for the covertices or the foci. I trust that you trust me at this point. Yeah, that's that for that one. Do notice on all of the sets of the vertices, the center, the covertices, the foci, all of them share some type of point with that center. So, and they all share between vertices, they have the same x value here. So if it's going to be wide, they'll have the same x value, but same x value for the covertices, same y value for the foci, same x value. If you find yourself with, let's say you don't have the point -3,6, maybe you have the point -2,6, that would, to me, immediately say something is wrong. Yeah, we have -2s on both of them, but not in the same slot. And it should share at least one of the values, one of the x or the y values. So just something to kind of keep in mind. All right. Find the center, vertices, and covertices, foci, lengths of the major and minor axes of the ellipse below given in standard form, then graph it. Woof. We'll start with getting that center. So the h value, the opposite sign, h is -1. There is no minus sign here, so that means k is 0. That means our center is at -1, 0. The bigger number is under the x, and so the bigger number is a squared is 36. That means a is equal to 6. That makes b squared 4, means b is equal to 2. C is equal to the square root of a squared minus b squared. A squared was 36, b squared was 4. So c is equal to the square root of 32. Which is approximately 32 square root, 5.7-ish. Just since we're going to plot it this time, 5.7-ish. All right. We can plot the center without knowing anything besides the center. So back -1, up 0. There's my center right there. And then in order to plot my vertices and my covertices, my foci, I need to know which is the major axis. The bigger number is under the x, which means the x-axis is the major axis. Which means that the vertices and the foci will be left and right of the center. Left and right of the center. So A is 6. I'm going to go, and sorry if you needed to write that down, take a moment, pause the video. what I love about doing this not in class, because I can say just pause the video. All right, I'm going to go to the left of the center, 6 units. So we have, let's see, one, is it going? There we go. 1, 2, 3, 4, 5, 6. And then 6 units the other direction and to the right. 1, 2, 3, 4, 5, 6. I have, these are both vertices here. One of them is at the point, let's see, -7, 0. The other one is at 5, 0, -7, 0, 5, 0. Co-vertices, you use the B value. This one will be going up and down. So we'll go 1, 2 units, 1, 2 units up, plot a point, co-vertices, 2 units. Go down 2 units, plot a point, 2 units down, another co-vertex. For the foci, we said this is around 5.7-ish. So you're going like 5.7-ish units to the left and right of the center. We know 5.7, it's almost 6, so it's going to be like somewhere in here. Oh, we forgot to do these labels. Let me do the labels on the co-vertices real quick. -1, 2, -1, -2. Those foci, because the center right here is at the point -1, 0. The thing that's changing on this foci here is you're taking and subtracting square root of 32 to get to this x value. So this focus right here will be at, you take the x value, but we're subtracting square root of 32, 0. -1 minus square root of 32, 0. And this one over here, this focus over here, we're taking the x value and adding square root of 32. So -1 plus square root of 32, 0. I want to point out that if you were to look at the formulas on the first page for a wide ellipse, that the formula is h plus or minus c, comma k. Or in our case, h is -1, k is 0, c is square root 32. So you'll see that those fall right in line with the formula on that first page. H is -1, c is square root of 32, so plus, there's the minus version, the plus version, and k is 0. Length of the major axis, this will be 2a. A was 6, so 2 times 6, which is 12. Length of the major axis is 12. Minor axis is 2b. 2 times b is 2. Length of the minor axis is 4. Last thing left to do is draw this ellipse. Let's see if I can get it nice and level again, since I did it once. Oh, look at that. A miracle. There it is, only a little bit tilted. You try your best, right? Boom. All right. Let's do one more. For this guy here, let's get the center first. So we have H is +5, opposite sign, remember? K is +2. That means the center is at the point 5, 2. Bigger number is under y, which means that that is going to be a. So a squared is 49, makes a 7. Because it's under y, that's going to be up and down from the center. This guy over here is b squared. B squared is 16, which makes b equal to 4. C is the square root of a squared minus b squared. A squared is 49, b squared is 16. So this will be the square root of 33. And the square root of 33, it's going to be very similar to the square root of 32, is like 5.7-ish. Was that exactly what we said up here? 5.7-ish? Yeah, 5.7-ish. All right, plotting my center first. My center is at 5/5 up to right here. I'm doing my vertices. We're doing up and down because we have a horizontal or a vertical, because we have a major axis that's the y-axis. When we talk about hyperbolas, then we talk about transverse axes, and that's all in my head right now. Anyway, up and down from the center, 7 units. 1, 2, 3, 4, 5, 6, 7. All right, 7 up. And then 7 down. 1, 2, 3, 4, 5, 6, 7. Okay. This point right here is the point 5, 9. Down here, we have the point 5, -5. So we have 5, 9. I'll do the bottom one first. 5, -5. So both of them. 5, -5. And 5, 9. The vertices are going to be left and right, or not, the co-vertices rather, left/right for my co-vertices of the center. So we are going 4 units to the right, one or left, 1, 2, 3, 4, and then to the right. So that's a co-vertex. 1, 2, 3, 4 units to the right, another co-vertex. So we have the point 1, 2 for this guy here. No. And then up here, this is going to be the point, let's see, 9, 2. So we have 1, 2, we have 9, 2. At this point, we have enough to draw ourselves the ellipse. We hope for the best. Oh, nope, that's not going to happen. Sometimes it decides to do it, sometimes it doesn't. You know, pretty good. A little tilted, but good enough. For the foci, those are going to exist on the major axis. They're going to be 5.7-ish units up from the up and down from the center. So 1, 2, 3, 4, 5, and a little bit more. And there's going to be one of the foci. That one's going to be it has the same x value as the center, so 5. And then it's going to be the y value of the center, but you add square root of 33. So 2 plus square root of 33. And then the other one will be 5, 2 minus square root of 33. So 5 and a little bit more units down. So 1, 2, 3, 4, 5, and a little bit more somewhere on there for the other focus. The length of the major axis is 2a. A in this case is 7, so 2 times 7 is 14. The length of the minor axis, 2b, so 2 times 4, which is 8. And there you go. That's everything I can teach you about graphing things in standard form. So in the next video, we'll talk about some other forms of an ellipse and go from there. All right, I'll see you in that video. Bye.